So, a huge paper has been retracted, and this paper has been the linchpin of hydroxychloroquine misinformation, where hydroxychloroquine was falsely misrepresented as a way to treat COVID, which it doesn't. It actually even makes COVID cases worse. And to top it all off, people with autoimmune conditions like lupus had to undergo a medication shortage because of this, where the consequences of going a long time missing this medication include things like severe lupus flare-ups, major organ damage, and sometimes even death. Now, what I want to talk about today is the retraction process and what it looks like and what it means. So, once a paper is published, there's three different things that can happen. The paper just sits and exists forever, the authors can issue a correction, or the authors and or journal can issue a retraction. Now, what's the difference between a correction and a retraction? A correction typically occurs around how the data has been processed, where maybe the grouping was messed up or the statistical analysis was incorrect. So the author and the journal put out a letter saying, hey, this is what the original text was, this is where it was incorrect, this is the new calculations, and this is the new results, and this is the new paper that has been corrected and updated with those results. Which as a scientist is embarrassing, but you caught your mistake, you corrected your mistake, you did the scientific process. A retraction, on the other hand, is much more severe. This means that there were critical mistakes in the paper, such as false conclusions drawn, having shoddy methods, and sometimes even ethical violations. And in this study, we're going to see all three. And what happens is sort of twofold. First, there's a retraction on the paper, and then when people go to download the PDF, there will be a big red rubber stamp on each of the pages saying retracted. And this stays like that because people will have downloaded your paper, people will have cited your paper, and this will let other scientists know that, hey, this information was incorrect, do not cite it, do not use it. If you do, it kind of makes you look like a shoddy scientist because your citations are poorly cited, meaning that you didn't have good scientific discernment, which is a fancy phrase we give scientists if they're really good at being able to say this is quality research versus this is shoddy research. Now, let's dive into this well-written article on this paper. On December 17th, 2024, the paper was officially retracted by the journal, which is a big deal because the authors are essentially saying we effed up. And the journal is also saying we didn't do our due diligence when we published this paper, where the paper was pulled because of ethical concerns and methodological problems according to the retraction notice. Two of the earliest issues of note were the small sample size of the patient pool, which isn't necessarily a problem, but we'll get into why it was in this case in a moment. But the more concerning issue is that the paper was submitted on March 16th, 2020 and was published 4 days later, which means that the paper had a non-critical review. So for a little background, what happens when you submit a paper is that you typically have 2 or 3 reviewers go through it. This is called peer review when you have 2 random scientists that also submit to the journal will go through and review your paper for free. So in theory, they go through and check the references of the paper to make sure they're accurately cited. They make sure that the methodology of the paper is sound, that the statistical analysis is run appropriately, that the tables and figures are accurate and include all of the data, and that the conclusions make sense. And typically this is a several week to couple month process, where your 2 reviewers will have essentially 3 options. They'll have accept as is, reject as is, or accept with minor or major changes. If there is an acceptance with minor or major changes, then there's a correspondence period between the authors and the reviewer to make sure that everyone gets in alignment and is happy with it. And then that reviewer can either accept it with changes or they can reject it, in which case the authors can submit for a 3rd reviewer to look at it, and if that person says yes and you have 2 out of 3, then you're published and you're good to go. So when we see that it was submitted on March 16th and it was published fully 4 days later, you can tell that the reviewers didn't do a very thorough job. And you might be thinking, well, why did this happen? Why was this allowed to even happen in the first place? Well, during publications, journals have a booklet of all their publications and they want to fill this out. So sometimes quick acceptances can occur to help pad the journal, especially if the author that submitted the publication has a long and extensive history of submitting to that journal successfully. And other times the authors are actually invited by the journal to write a publication, in which case the review is oftentimes much lighter, it just goes through an editor and then gets published. But either way, with only a 4-day review process to publication, they really didn't do their due diligence. Now, back to why that sample size was problematic, and that's because 6 patients that weren't included in that 36, so it would have been 42 patients, they had been treated with hydroxychloroquine and were dropped from the study, one of whom had died, which is a pretty significant endpoint, having a death in the study. and then 3 of whom had been transferred to intensive care, which is another important part of the study that should have been included. So dropping these 6 patients from the trial, massaging the data, very likely skewed the results in the drug's favor despite having 4 critical outcomes. But even with outcomes like this, oftentimes journals want more evidence, which can come from larger and more rigorous trials. And when these larger and more rigorous trials were performed, they showed that hydroxychloroquine did not benefit COVID-19 patients. So not only do we have blunders in the methodology, we also have other studies showing the opposite of what this study was showing. And then there were even more issues identified a few years later, where for some reasons the authors had a different cutoff for what consisted of a positive versus a negative COVID test in the control group versus the treatment group. This is an error because it should be exactly the same. If you have a higher viral load threshold that needs to be met, it's going to be harder for that group to have a positive test, which means that there would be a high degree of false negatives that would happen in that group. Or the false negative in this case would be a positive COVID test that would meet the viral threshold if it was in the other group, but it was classified as a negative. Finally, there was an ethics issue. So before I talk about that, let's talk about what standard test protocol is. When you're working with humans, you have to have standard of care be the control group, and then you have your experimental group, which is non-standard of care, where the point of this is to see if the experimental treatment is better than the current standard of care, or conversely if it's worse. It appears that they also use the antibiotic azithromycin in the control group, which would not be a part of the current standard of care, meaning that they didn't have a control group and experimental group, but they had 2 experimental groups. Meaning that they likely didn't fill out the appropriate forms, saying that, hey, this is a non-standard of care for our control group, and we need to have it so that you sign off on this, and that you consent to receiving this non-standard of care. Now, oftentimes papers like this can be retracted in silence, but this paper was actually the cornerstone of this huge push of prescribing hydroxychloroquine to all sorts of people. I'd go follow Bab's Zone, who's documented this out in detail, where this all started with America's Frontline Doctors and the Council for National Policy, and then got amplified by Trump, where again, this misinformation has had tangible harm on people, where people treated with hydroxychloroquine unnecessarily were endangered and experienced side effects like heart attacks, and then more importantly, people with autoimmune conditions like lupus who critically needed this medication had to go through a medication shortage and could not access it. Which is why prescribing medications, even in a time of health crisis, without solid proof of efficacy, and outside the rigorous framework of well-conducted clinical trials, remains unacceptable.